Hey everyone, welcome back to Cracking the GRE Math Subject Test. This is Calculus 2 and we are on question number 8. So in this question we're asked to find the perpendicular distance from the origin to the plane given by the equation x plus 2y plus 2z equals 6. So I'll just remind you that what we mean here is that if we have, let's say we have some plane, this is x, y, z. Let's say we have some plane here. Then we're looking for the distance between the origin and the plane. In other words, we're looking for the length of the line between the origin and some point on the plane, such that this line makes a right angle with the plane. In other words, it's perpendicular to the plane. Well, what you have to remember is that the normal vector to the plane, which is perpendicular to the plane, or one of them anyway, can be found easily by the coefficients of the x, the y, and the z in this equation. So in other words, the normal to the plane has the form 1, 2, 2. So every other normal is also going to be some scalar multiple of this normal. And this line, well, that's like a normal vector to the plane. So we just need to find the scalar. If we call this u, then u is going to be some scalar multiple of n. In other words, it's going to be of the form k, 2k, 2k. If we know what k is, then we can find the length of u. Well, let's see. We know that this vector u, it starts with the origin and it gets to some point on the plane. So if we know that this vector has to satisfy this equation, so let's plug it in for x, y, and z. We'll get k plus 2 times 2k plus 2 times 2k equals 6. And that gives us k and 4k makes 9k, which means that k is equal to 6/9 or 2/3. That means that our vector u is going to be, 2/3 times 1, 2, 2. So what's the length of this vector? Well, the length of u is just going to be 2/3 times the length of n, which is 1, 2, 2. So that's going to be 1 plus 4 plus 4. So that's going to be 2/3 times 2/3 times the square root of 9, which is 3. So that gives us 2, which is answer C.